Okay, I'm continuing on with the worksheet entitled Setting Up a Proper F-Test. I'm just giving you some examples of how to set up the problem. I'm looking at this sheet here. This is ask you to consider sample problem number 2. Test the null hypothesis at the 0.01 level. So this time our critical region is 0.01. That's the area. So it's smaller than the first example. Here's the null hypothesis. And listen to the hypothesis and think about the number of groups that we're comparing. College football players, baseball players, and volleyball players. So 3 groups. College football players, baseball players, volleyball players are all equal or the same regarding how much time they spend on their schoolwork. The unit of analysis for this problem essentially is the athlete. So consider the idea that there were 10 athletes from each of the 3 aforementioned sports. So we have 10 football players, 10 baseball players, and 10 volleyball players were randomly selected, and they were asked how much time they spend on schoolwork. So hopefully it's fairly obvious that n subtote, the total number of cases involved in the analysis would be 30. 10 athletes per sport, 3 sports, 3 times 10 is 30. I also ask you to assume a data generated F value of 4.35. So testing the null hypothesis at the 0.01 level, 3 groups, 30 cases total, and you've already been given your data generated F value. So let's look and see how this problem would be set up. Turn to the next page in that handout. The sheet, as you can see, that I'm referring to is sample problem number 2, drawing key. So once again, I drew the F probability distribution. I indicated a tail. I indicated how big that tail was. In this case, we were asked to test the null hypothesis at the 0.01 level, so that means that's the size of the critical region, 0.01. That means this piece has to be 0.99. And then I calculated degrees of freedom between. We've got 3 groups total, that's K. 3 minus 1, or K minus 1 would be 3 minus 1, which is 2. So degrees of freedom between, or degrees of freedom in the numerator, when we refer to the table, is 2. Degrees of freedom within, or degrees of freedom in the denominator, is 27. And we calculated that by taking the total number of cases in subtote, which is 30, minus K, which is 3. 30 minus 3 is 27. So degrees of freedom in the numerator, 2. Degrees of freedom in the denominator, 27. Alpha level of 0.01. I then consulted the F table. Degrees of freedom in the numerator is 2. Degrees of freedom in the denominator is 27. And a 0.01 alpha level, which is the 0.01 level. So we consulted the bold. And if I read the table correctly, that means that our tabled F value is 5.49. That is up to the amount. That is the maximum amount of between group variance we could expect to occur by chance alone, assuming 3 groups, a total of 30 cases, and a 0.01 level. I know that's a mouthful, but that's really what that number means. Tabled F, 5.49. That's the maximum amount of between group variance we could expect to occur by chance given these conditions, okay? I then asked, if you recall from the previous page, assume a data generated F value of 4.35. Well, if 5.49 is here, where would F of 4.35 fall? Right here. We did not fall in the rejection region. We did not exceed the amount of between group variance we could expect to occur by chance alone. Therefore, we should retain or keep the null hypothesis of equality. We can declare those three groups equal. The 3 groups are statistically the same. That's saying the same thing. They're equal. They're statistically the same regarding the amount of time spent on their schoolwork. The amount of between group variance that we observed could have reasonably occurred due to chance or sampling error alone. Problem number 3. Test the null hypothesis at the, this time it says the 0.05 level. So that's our critical region. Here's the null hypothesis. 5 professions, so those are the 5 groups we're comparing. 5 professions: stock traders, train engineers, snowplow drivers, college professors, and small business owners are all equal or are all the same regarding how many books they read for recreation. So we need to make the decision, are we going to retain or reject that null hypothesis? So our unit of analysis is the worker or the professional. I'm asking you to assume that we randomly drew 7 members from each of those 5 professions for a total of 35 people involved in the analysis. 5 professions times 7 people drawn randomly from each is 35. So we have, and I'm also, as you can see, asking you to assume a data-generated F value of 2.17. That's the actual amount of between group variance that we observed. So let's turn to the drawing, the last page in that handout. Sample problem number 3, drawing and key. Again, I drew the F probability distribution, indicated a tail, indicated the size of the tail, 0.05. How did I know it was 0.05? Because that's the level at which we were asked to test the hypothesis. This portion is 0.95. Degrees of freedom between, or the numerator, is k minus 1, or our number of groups minus 1. There's 5 professions or 5 groups. 5 minus 1 is 4. Degrees of freedom within, or the denominator, is 30. There were 35 people total involved in the analysis, minus k, 5 groups, so 35 minus 5 is 30. And the alpha level is simply the size of our critical region, the rigor with which we were asked to test the hypothesis. So our alpha level is 0.05. So given this information, degrees of freedom of 4 in the numerator, degrees of freedom of 30 in the denominator, and an alpha level of 0.05, I then consulted the table and determined the tabled t-value is 2.92. And again, that is the maximum amount of between group variance we could expect to occur by chance if we were analyzing 5 groups and had a total of 35 cases, or degrees of freedom 4, degrees of freedom 30. How much between group variance did we actually observe? Well, that's our data generated F value. Data generated F is the actual amount of between group variance that we observe. Where does that fall? Well, if 2.92 is here, that means 2.17 falls here. That's the actual amount that we observed. That was the amount that was given on this sheet here, 2.17. So the 5 groups are therefore the same. We should retain or keep the null hypothesis of equality. The amount, then this is the key statement, the amount of between group variance we observe could have occurred simply due to chance or sampling error alone. Again, F tests are all about comparing more than 2 groups simultaneously in order to determine if those 3 or more, depending on how many groups are in your analysis, if those 3 or more groups differ significantly from one another simultaneously at the same time. So, in sum, with that sheet, with this handout here, with this handout here, all I'm asking you to do is to work through or read through those. Make sure you do. Please go back. I didn't want to read the whole thing to you, but go back and read for each of those problems. Read through the whole thing, but also make a point of noting the note/explanation so you fully understand where all the information came from. And again, I just wanted to provide you with some examples of how to set up, how to properly set up the F test. I have another segment I'm going to share with you where I kind of go, as I've said before, cradle to grave with a null hypothesis and some actual data to walk you through that. I followed the exact steps that I presented you with in the first week's information regarding F tests and one-way analysis of variance. So please, if you need to review that, obviously it's at your disposal to do so. So the next segment is going to be walking through an example from beginning to end, which is what you're going to need to be able to do on your problem set for this week.